Good day, welcome to Lesson 1 of ENVS 256 Air Quality Control. Today's lesson we will be looking at an overview of the topic of air pollution. At the end of today's session, we would expect that you would be able to discuss some of the global, regional, and local problems that would be associated with atmospheric pollution. Now, some of these problems may be the same, both global, regional, and local. The only difference may be as a result of it may be different because of scale. But typically you tend to find this problem of air pollution, the factors, causes, etc., results being very similar across scales. Additionally, we would look at some sources of air pollution and how we classify the various forms of pollution, and we would also look at how air pollution can affect human health. Now we will begin by looking first at a definition of air pollution. According to the US EPA 2007, the presence of contaminants or pollutant substances in the air can interfere with human health and welfare or produce other harmful environmental effects. Now note, the effects we're talking about not only from the perspective of human health, but also the environmental effects. And remember, when we talk about the environment, there's so many different ecosystems and so many components of each system that make up our environment, both the living and non-living environments. So how can we know when we have air pollution taking place? Typically, the first things that we can use can be our five senses. Can we see? Can we smell? Can we touch? Can we hear? Feel, etc. Okay, so some of the alerts to air pollution would be, for example, you can smell smoke in the air. There may be unpleasant odors as a result of many different sources and contributions to air pollution. It's also important to note, though, that some pollutants, it's not easy to sense them at all. Some gases, for example, it may be odorless, you can't smell it. It may be colorless, you can't see it. Some examples would be carbon monoxide, carbon dioxide, radon, etc. So where you have situations for potential release of some of these gases, harmful gases, and particularly when they reach a certain threshold, when you pass that threshold of release into the atmosphere, that's when it becomes dangerous. So if there is a risk of that, this is when it's very important for you to be monitoring. You can also observe pollution if you have health effects, such as the development of respiratory problems such as asthma, chronic bronchitis, pneumonia, etc. Now, some of these diseases may be hereditary, but many of the cases in more recent times seem to be cases that develop over time. And this may be an indication of the link to air pollution. Additionally, you may find increasing numbers of immune system disorders like rheumatic fever, celiac diseases, and other types of autoimmune diseases. Some of the environmental effects as well can also be seen in the deteriorating health of vegetation, forest health, even agricultural produce and agricultural plant produce, etc. So we can see some of the effects there. Acid rain, so the acid rain can affect vegetation, we know it can affect buildings, etc. So there are many different environmental evidences that can be linked back to air pollution. So how do we classify air pollutants? We can classify air pollutants according to the following characteristics. We can look at the origin of the pollutant, where does it come from, the chemical composition, and the state of matter. So let us look at each one in turn so that we can understand it a little better. So we have pollutants that can be both primary and secondary. Let's make sure that we understand the distinction between the two. So if I can direct you to the diagram on the right of the screen, we can see that many primary pollutants, it can come from both natural and man-made sources. So some natural sources or origins of air pollution can be, for example, wind. The wind can transfer some of those, like dust, for example. Think about the Sahara. Dust can be transported from one continent across the oceans to another. We deal with that often in Trinidad and Tobago, and in recent years it has been getting worse. Other natural sources may be from volcanic eruptions, where a lot of ash and sulfur dioxide can be released into the atmosphere. Then we can also have secondary, I beg your pardon, we can also have human influenced sources of primary pollutants, in the form of pollutants that would be released from human activities such as factories and plants. We will also have the use of the multitudes of vehicles and the combustion of those vehicles releasing pollutants into our atmosphere. So these would be sources of primary pollutants. Now if we look at the secondary pollutants, we see here that primary pollutants can actually contribute to this second category of secondary pollutants. So what actually happens is these pollutants now will interact with the light chemical, the light and the heat in the atmosphere. We'll have a chemical reaction that takes place where new chemical combinations and molecules are formed, and the result of that would be acid rain. So if you look at some of the chemicals that have been produced there, these are some various forms of acid rain that can result. Chemical composition now. So we just looked at origin. Let's look at chemical composition. So we can classify air pollutants according to organic compounds and inorganic compounds. Now very simply, our organic compounds, these are any members of a large class of gases, liquid or solid chemical compounds whose molecules contain carbon. The inorganic are any substances in which two or more elements other than the carbon combine. So essentially, so let's just make note of that last statement at the bottom there. The primary difference between organic compounds and inorganic compounds is that the organic compounds always contain carbon, while most inorganic compounds do not contain carbon. So let's continue. State of matter. Right. So these major states of matter that the categories we would look at would be our particulates. Then our gases, as we already learned, for example, can be organic and inorganic. So particulates would be, as the word suggests, particles, right? These particles can be presented in the form of solids or even liquids. For example, what are examples of those? So solids, you're talking about things like dust, smoke, fumes, etc. Liquids, we can actually mist and spray, and we can actually have tiny particles in the midst of all of that as well. So these can actually manifest as air pollution. Our organic gases, some examples of organic gaseous pollutants would be hexane, benzene, formaldehyde, acetone, etc. And some inorganic examples would be carbon monoxide, carbon dioxide, sulfur dioxide, etc. So we have a number of them here. So what I would really require from you is not only to know what these classes are, but be able to give an example or two. So let's talk a bit about particulate matter. Remember, we're talking about particles. We can classify particles into two categories: our fine particles, or PM 2.5 or PM2 as they would say, larger particles PM10. Those are really a reflection of the size of the particles. Okay, so what is PM2? Research has shown that exposure to these fine or small particles is most likely to lead to health problems than to exposure of the larger particles. The small particles are able to penetrate further into your lungs and are likely to be more bioavailable than the larger ones, meaning that because it's so small, it's much easier to get into your body systems and cause damage to your system. So it's not only get into your lungs and stay there, but it can actually travel through your biological systems and cause damage. The larger particles, PM10, have been linked, these coarser particles have been linked to other chronic diseases like your respiratory diseases, asthma, etc. So here we have a nice little schematic to help us somewhat visualize the differences in size of these particle matter. For example, what do we have here? So PM 2.5, basically it refers to the measurement 2.5 microns or micrometers in diameter of the particle. That is very, very tiny. PM10 is 10 microns or micrometers in diameter. So PM 2.5 is much smaller than PM10. Now let's look at this in context in terms of sizes that we can more relate to. For example, this is fine beach sand, not coarse but fine. The average size of this is 90 microns. We have a strand of hair. The diameter of this could be anywhere between 50 to 70 microns. Okay, now let's look at this. How many PM10 particles have to come together to make up the diameter of the human hair? So here we have 1, 2, 3, 4, 5. So that's 10 of them. The blue circle represents the relative size of the larger particles, PM10. Now notice you have several of the PM2 have to be formed together to make up one PM10 particle. Okay, so that means it's pretty small. It's very, very small. That is why oftentimes you could be breathing in particles and you have no idea that you're breathing in such fine particles, because they are so tiny, they're getting into your lungs and your system very easily. Oftentimes with the PM10, like the dust and the pollen, sometimes we know, depending on how coarse it is, sometimes we can know. Alright, so as you can see here, some examples of the PM2 would be particles from combustion that have been released into the atmosphere, some organic compounds, metals, etc. Okay, so let us now look at some natural sources of particulate matter. As we mentioned before, volcanic eruptions can release a lot of particulate matter into the atmosphere in the form of ash. When the ash is released into the atmosphere, it can also, if it's done on a large scale, it can actually block out a lot of the sunlight. There have been instances in the past where For example, I don't recall the exact year, but there were massive volcanic eruptions in Iceland that caused some massive cover, volcanic cover across significant parts of Europe, where for days airline activity had to cease because visibility was so bad. So that can actually be a serious situation depending on how massive they release into the atmospheres. Then we can also have particulate matter. Remember we mentioned liquid, gas, gaseous, mist, etc. So sea spray can release particulate matter into the air as well. Dissolve salts, etc. And you can also have decaying matter as a source of major source of reactive sulfur, decaying vegetative matter. Then we can, every one of us knows about this one. We have massive forest fires across the world in recent years. These forest fires release a lot of smoke and a lot of particles into the air that can actually also, similar to the result of the release of volcanic ash, can create great clouds across massive regions, blocking out sunlight, creating problems for people to breathe, etc. So forest fires can also be a problem. Trees and bushfires, these can emit volatile organic compounds, pollen, spores, bacteria, and even smoke into the atmosphere. Again, places like Trinidad and Tobago, seasonally we often have a problem with this, with the bushfires. So this can also create a lot of problems for persons with respiratory illnesses during these times. Then some parts of the world have dust storms. So here again it's a natural process, but this natural process is releasing a lot of larger particulate matter into the air, creating all kinds of problems for both human health and the environment. So let's look at anthropogenic air pollution now. We just looked at natural sources. Let's look at how human activities can result in air pollution. So one of the most obvious things that we would observe that result from human activities would be smog. So smog, this is an atmospheric condition that is characterized by significant reduction in visibility. Typically it tends to happen when temperatures are high. Now, for example, we right here in Trinidad, we experience this a lot. Many of you would often see, if you're coming into Port of Spain, mainly in the morning time, for example, visibility coming into Port of Spain would often be very poor. You would look over the horizon and you cannot clearly see outlines of buildings, etc. So this is an example of smog or pollution in the air at that point in time. As I mentioned before, there are many cities in the world that actually experience this as such extreme conditions that that activities have to be shut down for a period of time in order to allow usually like winds, etc., to clear the air and the atmosphere for things to get back to normal. Okay, so still talking about smog. Smog is used to describe the type of fog which has smoke or soot in it. So what we're saying is there's a lot of particulate matter contained within this fog. The smog itself is a yellowish or blackish fog formed mainly by the mixture of pollutants in the atmosphere, which consist of fine particles and ground level ozone. So ground level ozone is a type of gas, normally colorless, and it can also be highly irritating to your respiratory system. Okay, Um, Smog, which occurs mainly because of air pollution, can also be defined as a mixture of various gases with dust and water vapor. So see, we have the various matters mixed up there. We have the particulates, we have gases, and we have moisture. And smog also refers to hazy air that makes breathing difficult. So typically, respiratory illnesses and respiratory difficulties will result from the presence of smog. Haze, this is often occurs over a large scale. This is low level pollution now. All right, low level pollution, usually resulting in reduction of visibility. So it's very similar to that of the fog. This is typically caused by suspended particles. Okay, so it may not have as much compositions of the various gases, or even as much moisture such as you would find with smog. Okay, but you can also have a lot of similar respiratory problems associated with this. For example, you can have inflammation of the eye, so that would be swollen eyes, irritated eyes, nasal irritation that can result in a lot of mucus production. Your throat could be irritated as well. Lung inflammation and scarring as well can result from the pollutants contained in the haze in the atmosphere when this occurs. So we have a lot of respiratory discomfort, respiratory irritation that can occur. Still talking about human caused air pollution. So we can have some non-traditional air pollutants as well. So we have been talking so far mainly about things like dust, gases, moisture in the atmosphere. Now pollutants can also come in, air pollution can also come in the form of noise, because remember, noise is a type of energy, or sound is a type of energy that travels through air, right? So you can have noise pollution in the sense that if the noise or the sounds exceed what is acceptable according to authorized standards. For example, EMA has noise pollution standards. Sounds or noise that exceed those standards would be considered as air pollution. Then heat and other forms of radiation released into the atmosphere. For example, you're talking about radiation such as X-rays, gamma rays. You all will be familiar with those. That can be released into the atmosphere as well, and these things can actually cause problems for the human body. Sometimes it may not be immediately observable, but too much of it over time can cause problems. For example, here we also talking about a non-traditional type of air pollutant would be electromagnetic fields. If we look here for the definition, it is a physical field. So remember, it's a type of energy that's produced by moving electrically charged objects. What does that do? That can cause heating of body tissues. So imagine if your body had to be facing that over a prolonged period of time. Obviously, it will throw your biological processes out of order, and more these days science is beginning to realize that many of the things that the human body faces as a result of what is happening in our environment, the results of it on the human health are sometimes difficult to anticipate. Okay, other types of sources of air pollution, gases and particles in the form of solid and liquid particles, aerosols, etc. So let's talk a bit more about the effect on human health. So we touched on particulates already. We know particulates can have effects on the respiratory system, where we'd have things like asthma, bronchitis, and other type problems, lung infections, scarring of the lungs, etc. Particulates, particularly the fine ones, can lead to disruption in the nervous system. So then remember, the nervous system is one of the biological systems in the human body. It's very important to the functioning of the human body. Particulates can lead to allergic reactions, for example, sneezing, itching, coughing, etc. Swollen eyes, itchy eyes, all of these things can result. Then we have the organic compounds, which can result from some of the primary pollutants, both natural and human induced. And some of these organic compounds, again, similarly, it can also affect your central nervous system. It can cause headaches, cause you to go into a coma, etc. An example of that would be carbon monoxide. Second example, there we have sulfur dioxide, can lead to symptoms such as nosebleeds, disruption to your digestive system, where your digestive tract is affected. Okay, all right, so let us look a bit again at those sources of pollution. So we know we have the primary pollutants, and we talked about some of those already. Then we also have what we can call or classify as mobile or stationary. So mobile pollutants would be any air pollutant emitted by objects that move, such as automobiles, airplanes, locomotives, etc. And of course, if these things move, and then imagine now if you add the element of wind currents or even ocean currents to pollutants, you have an issue of air pollution that can now become cross-regional or even global, depending on the scale of it, as these things can now move these pollutants out of the area of origin. Then you have stationary sources, where there's any fixed emitter of air pollutants, such as fossil fuel burning power plants, petroleum refineries, etc. So they are fixed because you can actually identify a physical geographic location for these sources. So we call them stationary sources. Then we also have area or point sources of pollution, which is any single identifiable source of pollution from which pollutants are discharged, such as a pipe, a ditch, factory, or ship smokestack. Those would be examples of points. And an area source can be, for example, a farm that releases farming activities that releases methane into the environment, for example. Remember, the farm would not necessarily be a point in the way a pipe leak would be, but it would actually be a larger area. Other sources may be from combustion or non-combustion. So combustion sources would involve things like the generation of electricity, road transportation, navigation. Remember, fuel has to be burned by these types of activities, and the burning of fuel will release pollutants into the atmosphere. Then we also have non-combustion sources. Those remaining sources that do not involve combustion. Major sources of VOCs would include paints, solvents, consumer products, printing, etc. All right, so those types of sources do not involve burning of fuels. Then we have direct and indirect sources. So as a result of human activity, of substances or heat into land or water, which can be harmful to human health or the quality of the ecosystems, both aquatic and terrestrial. Alright, so it can be direct or indirect, because remember, sometimes, for example, if you look at the formation of acid rain, the formation of acid rain has to go through different stages before it becomes acid rain. So that might be an example of an indirect source of pollution. Then we have secondary sources of pollution. These are produced in the atmosphere as a result of the chemical reactions. Again, another good example is the formation of acid rain as a result of this photochemical process that takes place. So in conclusion, this graph shows us some various sources of air pollutants. So we already know what particulate materials are, so some activities that will contribute to that, or sources, for example, agriculture, paving of roads, unpaved roads, construction, etc. All of these activities will contribute to particulate matter. Remember, of course, you have both primary and secondary sources. You have natural sources, and you also have human activities that lead to air pollution. Lead is also another pollutant when released into the environment. Some sources would be from waste, transportation methods, etc. Nitrogen oxide, carbon monoxide, volatile organic compounds, and sulfur dioxide. So I would encourage you to take a look at this chart and make sure that you are able to identify at least one source for each of these categories. And these are our references. So I want to thank you for joining me today for today's lesson. Please now proceed to the activity that has been provided for this week. Thank you.